So today we are going to discuss about tensile strength of concrete. So if you want to find out tensile strength of concrete in laboratory, then how to proceed further. Okay. So basically there are two tests that we are conducting to find out the tensile strength of concrete. It is not the direct tension that we are applying. It is indirect tension. So first is flexural strength. So basically, whenever such a specimen that is like a beam, when you are applying such load, bending load, then it will try to bend. So at the top portion, generally compression would be developed and bottom tension would be developed. So indirectly in bending, whenever we are loading the specimen and whatever that modulus of rupture that we are finding, that we are using to find out the flexural strength of concrete. Okay, and next is split cylinder test. So whatever that cylindrical specimen that we are using for compression test, same specimen we are using, but we are keeping it horizontal. And here again, same compression testing machine that we are using, and we try to apply the load. So top and bottom portion, almost 1/6 portion, that would be under compression, but the rest of the portion it will be under tension. So basically, you should understand that we are not giving direct tension; it is indirect tension, either in the form of bending or either in the form of that splitting the cylinder in a particular direction for giving tension. So basically, why this tensile strength is very important, because concrete is, as you know, strong in compression and weak in tension. And whenever we are doing RCC design, generally tensile strength of the concrete for which we are designing and reinforcing bars that we are providing to resist the tensile force. But that doesn't mean that tensile stress output nothing. Okay. But however, these tensile stresses are likely to develop in concrete due to various reasons like drying shrinkage, rusting of steel reinforcement, temperature gradient, and many other reasons. So due to that, a certain amount of tensile stresses are always there. Okay. So therefore, it is necessary for you to know the tensile strength of concrete also, apart from compressive strength. And whenever we are talking about the concrete road slab, okay, here also tensile stresses are developed, and there are two principal sources: will load, okay, and also volume change in concrete due to various reasons. So it is necessary that this will load, which is coming, it cause high tensile stress due to bending. જ્યારે જ્યારે બિલ લોડ પડે ત્યારે બેન્ડ થાય, બરાબર. સો બેઝિકલી ધ ફ્લેક્ઝરલ સ્ટ્રેસીસ, જ્યારે બેન્ડિંગ થાય તો એને જે સ્ટ્રેસીસ ડેવલપ થાય, that is generally called as the flexural stresses. Okay, and it is possible when there is a inadequate subgrade support. So as I told you that direct measurement of tensile strength of concrete is very difficult, because it is very difficult to pull your testing specimen. Neither the specimen nor the testing apparatus that have been designed which will ensure that the uniform distribution of the pull can be applied to the concrete. So it is very difficult to pull the concrete specimen. So what we have to do? We have to apply the indirect tension. Okay, and there are two test methods that we are using to find out the tensile strength of concrete, and that is determination of flexural strength. And whenever I am talking about flexural strength, it is under bending. Okay, so it is generally conducted by the beam test under bending. Bending के वक्त जो भी stress develop होता है by the indirect tension, that is generally the flexural strength. Okay, and split cylinder test. So here indirect tension is applied in the form of splitting. दो पार्ट में convert हो जाएगा, दो पार्ट में split हो जाएगा cylinder. Okay, so the position of the cylinder, it would be horizontal, not vertical. Okay, so both the tests we will be discussing now in detail. So first test, it is determination of flexural strength of concrete using beam specimen. Okay. So basically this flexural strength of the concrete is the ability of the beam or slab to resist the failure in bending. जो भी bending में जो failure होता है उसको resist करना है, that will be done by this flexural strength. And this beam test, they are generally considered to be very good to measure this flexural strength property of concrete. And this flexural strength is generally expressed in terms of modulus of rupture. Okay, and that is in Newton per mm square. So this modulus of rupture, it is a measurement of tensile strength of concrete for beam or slab specimen. And this flexural strength identifies the amount of stress and force in unreinforced concrete slab, beam or other structure that can withstand such that it resists any bending failure. So just in simple term, you can say that it is used to find out the tensile strength of a beam or slab specimen under bending. Okay, so that is the ability of the beam or slab to resist the failure under bending. Okay, so this value of modulus of rupture at the extreme fiber stress in bending depends on the dimensions of the beam and manner of loading. So this is very important. कि beam का size क्या है, आप कैसे load apply करो. These are the two, because that will change your particular modulus of rupture. So there are two ways in which you can find out this particular flexural strength by applying the flexural tension. Okay. So first loading condition is center point loading and third point loading. So so here दो point loading condition है. So first is center point loading. So here you can see this is your beam specimen, and here at center you have to apply your load. So which is called as center point loading. Exactly आपका जो भी specimen है उसके center पे आपको load apply करना है. Okay, so this is the span length. जो rollers है उसके ऊपर आपको ये रखना है आपका specimen, and this span length that is generally 600 mm, 60 centimeter. Okay, and exactly at the center you have to apply the load. And second is third point loading. So basically, if suppose this is your span length L, it is 3 times of D. अगर L आपका 60 centimeter है, so exactly at 20 centimeter, so means it is uniform loading that you are applying at exactly 1/3 post part. Okay, and that is called as the third point loading method. So these are the two loading methods that are generally used to apply this flexural tension. Okay. So in case of the symmetrical 2-point loading, means this way if you are applying this load, which is called as the symmetrical 2-point loading, exactly at the distance L/3, you can say. Okay, and then the critical crack, it may appear at any section and not strong enough to resist the stress within the middle third. So exactly यहीं पे आए ऐसा कोई जरूरी नहीं है. Okay, it may come up here also, it may come up here also, crack. Okay, where the bending moment is maximum. So exactly it may not come at this जहाँ पे bending moment सबसे ज़्यादा होती है. But in case of center point loading, the maximum fiber stress will come below the point of loading. So here the crack would be developed. Okay. So here this is the thing how this loading condition that will be differing in both the types of loading, because it will affect the crack or the failure mechanism. Center point किया तो exactly at the center आएगा, but if you are loading with this third point loading, it may not be coming exactly at the center, it may come anywhere. Okay, so that distance is very important. So this is the principle behind the flexural testing, center point loading or third point loading. So basically 2-point loading, it will yield a lower value of modulus of rupture than the center point loading. So here some of the results that are given. On y-axis we are having modulus of rupture, and this is beam depth and width. So you can see that center point loading, all the values are higher. Okay, and this third point loading, the modulus of rupture, that is coming less. So this way, which type of loading you are applying, that will also change your particular value of modulus of rupture, and ultimately modulus of rupture itself is called as the flexural strength of concrete. So which type of loading that you are applying, that you have to mention whenever you are doing flexural testing. Okay, so this figure, it is very important, and that will show you how this loading condition can change your value of modulus of rupture, and ultimately it's a flexural strength. And our IS 516/1959, it specify the 2-point loading. Okay, so testing machine may be of any reliable type of sufficient capacity for the test, and we have to apply load at a specified rate only, and the permissible error, it may be around plus or minus 0.5% of the applied load, where high degree of accuracy required, or otherwise you can maximum allow the variation of plus or minus 1.5%, but not greater than that for generally commercial type of use. Okay, so here this is the setup which is generally used for the flexural strength of concrete. So I will explain you how this setup is done. So here, this bed of the testing machine, it should be provided with the two steel rollers. So here you can see there are two steel rollers that are provided, that are 38 diameter, two rollers, and that are provided at the distance, center to center distance of center to center of 60 centimeter for 15 centimeter specimen. Here there is a typing mistake, it is centimeter, and for 10 centimeter specimen it should be 40. So normally we are using 15 centimeter specimen, 15 by 15 by 70 centimeter, जो भी बीम का साइज है 15 by 15 by 70 लेते हैं, तो हमारा जो डिस्टेंस होगा बिटवीन दिस टू रोलर्स इट वुड बी 60 centimeter. Okay, so these are the bottom rollers above which you have to keep your particular specimen. Okay, ये जो beam specimen है that we have to keep on this particular roller. Now above this again two rollers are provided, same 38 diameter, two rollers are again provided, and the center to center distance between these two rollers it would be 20 centimeter for particular our size of specimen, that is 15 के लिए 20 and 13.3 centimeter for the 10 centimeter specimen. So we will say that in our case it would be 20 centimeter because our size of the specimen would be 15 by 15 by 70, and this is again for the center point rolling. Okay, so basically this is the test setup that is generally available in every lab where you have to check this particular flexural strength of concrete, and this load is divided equally between the two loading rollers. So equally it can divide your load, so exactly at L/3 portion this load can be applied. Okay, and it is applied in such a way that it applied axially without subjecting specimen to any torsional stresses or strain. So this loading setup that you should understand, where we have to keep our particular specimen. Okay, so generally standard size of specimen, as I have told you, so this is your mold in which you have to cast your particular beam. So the size of specimen should be 15 by 15 by 70 centimeter, and if the largest nominal size of the aggregate does not exceed 20 then in that case you can have the size of specimen 10 by 10 by 50 centimeter can also be used. So generally for casting the cubes we need some mold. So this mold may be either of metal, preferably steel or cast iron. Okay, and it should facilitate the removal of molded specimen without damage. Now initially we have to do the tamping. जो भी हम concrete proportion that we are deciding, that is to be properly thoroughly mixed. So for that we are generally using this tamping bar. Okay, so this tamping steel bar, it may be of weight that is 2 kg, 40 centimeter long, and should have reaming face of 25 mm square. Okay, so this particular tamping bar we are using just to tamp the concrete, and then after just we are keeping it on vibrating table. Okay, so whatever desired as per design, you have to prepare your cube, sorry, not cube, it's a beam. Okay, so once it is done, after compression testing machine, full compaction is applied. This test specimen are stored in water at temperature of 20 to 30 degree for 48 hours before testing. अभी आपको टेस्ट करना है. ओके, सो बिफोर टेस्टिंग यू हैव टू, so generally we are applying the curing period. That curing period would be 28 days. Okay, and before testing, at least for 48 hours it should be stored in water. Okay, so it should be tested immediately on removal of water. ऐसा नहीं कि 1 घंटे बाद हमने किया, 2 घंटे बाद किया. So it will be a varying degree of dryness. So we don't want that. We have to just take out the specimen from the curing tank and you have to immediately test it. And you have to note down the dimension of specimen as per our requirement. Okay, before testing. And no preparation of the surface is required. In case of cylinder, we are doing capping. But here there is no need to go for such preparation. जो भी आपका specimen है, just you have to apply on the machine. Okay, so you have to place your specimen in testing machine. So this bearing surface or supporting and loading rollers सबको आपको clean करना है, and any loose or sand material is there that you have to remove. Okay, and then specimen is placed on the machine in such a manner that the load is applied at the uppermost part of casting mold. जो भी आपने proper किया है, casting किया है beam, उसके ऊपर अच्छे से लोड अप्लाई कर पाओ, ठीक है, along the two lines which are spaced at this, so exactly at 1/3 portion that you have to apply the load, and the axis of the specimen is carefully aligned with the axis of the loading device. So proper application of load is very important, and this load should be applied without shock, and it should be increased continuously at the particular rate such that the extreme fiber stresses increases at a approximately 0.7 kg per square centimeter per minute. So you can say that the rate of loading would be around 400 kg per minute for 15 centimeter specimen and 180 kg per minute for 10 centimeter specimen. So this loading, how to apply the load, that is very important, and how you are keeping your specimen under your testing machine is equally important. And when the load is increased until the specimen fails, and you have to find out this maximum load, okay, and that you have to note down कि load कितने load पे आपका fail हुआ specimen, and also you have to observe the appearance of the fractured faces of the concrete and any unusual features in the type of the failure is noted. So किस type का failure हुआ है, crack कहाँ पे हुई है, कितने distance से हुई, that all you have to note down. Okay, so here this is the actual test specimen that is under testing machine. So these are the two rollers, bottom rollers, and under which you have to keep your particular specimen, and then you have to, this is 1/3 loading. So here this crack is observed. Okay, so this flexural strength of the specimen, as I told you, it is expressed in terms of modulus of rupture. So now what is this modulus of rupture? So this is the formula for finding out the modulus of rupture, which is equivalent to flexural strength of concrete. तो ये जो modulus of rupture है वो ही आपकी flexural strength है. Okay, so it is m by z. So this sectional modulus, it is I by y. Okay, and that is already you are knowing z is 1/6 bd square. So here all these dimensions are given. This length, it is not the length of specimen, it is the center to center distance between two rollers. Okay, this L. Okay, and this is L by 3 equally spaced, and this distance A, here suppose the crack is observed, so this is your A distance, and from the top you are applying the load P. Okay, and this is your depth of the specimen. Okay, this is your depth of the specimen. Now this z is equal to 1/6 bd square. So you can say modulus of rupture is equal to 6m upon bd square. Now depending upon your fracture के जो भी क्रैक हुआ है कहाँ पे डेवलप हुआ है, accordingly you have to find out your flexural strength. So if this A distance, the distance of your particular crack from your nearest support of your roller, वहाँ से आपको मेजर करना है, ठीक है. If this A distance is greater than 20 centimeter for 15 centimeter specimen, or it is greater than 13.3 for 10 centimeter specimen, जो आपका L by 3 portion है वो आपका कितना आया 20, ठीक है, L by 3, because this center to center distance is 60 centimeter. तो अगर 20 से ज़्यादा है for our 15 centimeter specimen, then your bending moment, this maximum bending moment M, it would be P by 2 into L by 3, that is PL by 6. So in that case this Z is equal to 1/6 bd square. So here you can get this FB is equal to PL upon BD square. Okay, so this is the value of flexural strength of concrete. So P is known to you, the span is known to you, B and D both are the dimensions of your specimen. Okay, and both are 15 by 15. So everything is known to you. So you can find out flexural strength of concrete equivalent to modulus of rupture. But if your A distance वो 20 से कम है, मतलब ये L by 3 के इस तरफ आ रहा है, इधर कहीं क्रैक आ रहा है, ठीक है, so that is, but it is between 17 to 20 centimeter. It is less than 20, but 17 से 20 के बीच में है for 15 centimeter specimen, और 11 से 13.3 के बीच में है for the 10 centimeter specimen. This cannot be taken as L by 3. L by 3 नहीं ले सकते, आपको exactly A value लेना पड़ेगा, ठीक है. So moment would be P by 2 into A. So that is PA by 2. And Z would be 1/6 BD square. So this FB value, that is flexural strength value that you are getting, it is coming out to be 3 PA upon BD square. So generally this flexural strength value, this two, that can be find out based upon the crack which is developed and its distance from your particular nearest support. So with this D, as you know, it is the depth of specimen at the point of failure. L is the length of span, not the specimen. Specimen की length तो 70 है, span length is 60 centimeter. And P is the maximum load at which this failure occur. If the third condition, now if your A is less than 17 centimeter, मतलब बहुत ही कम एकदम नजदीक आ रहा है, nearer to your support, that is the third case. So this is your first case, this is your second case, and this is your third case. If your distance A is very nearer to your support, means less than 17 centimeter for 15 centimeter specimen, or it is less than 11 in case of 10 centimeter specimen, the results of the test are discarded. इतना नजदीक नहीं आना चाहिए. Your result is not good. Again you have to cast the specimen. Again you have to do testing. Okay. So this way you have to carry out the flexural strength of concrete. Okay. So next is split cylinder test. So here also indirectly you have to apply tension. We are not going to pull the concrete block specimen. We are just applying indirect tension. So here the principle is that normal compression testing machine, with the help of which we are applying the compressive load. So it is observed that the top portion and bottom portion that are under compression, but the rest of the particular part that would be coming under tension. And so you have to observe the failure plane and you have to find out the maximum load. So in this case what will happen, this particular cylinder, it will be split in two parts exactly. तो एग्जैक्टली ये दो पार्ट में डिवाइड हो जाएगा. दैट्स व्हाई इट इज कॉल्ड एज स्प्लिट सिलेंडर टेस्ट, बिकॉज the whole cylinder जो हम horizontally we are keeping, that will be split in two direction. Okay, so generally the normal cylinder that we are using, that is the 15 centimeter diameter by 30 centimeter height, the same cylinder we have to use for this tension test also. Okay, it is not a different one. It is the same cylinder that you are using for compression test, the same can be utilized for split cylinder test. So this is the cylinder splitting or split cylinder test, or also called as the Brazilian test. And as it was developed in Brazil in 1943, and simultaneously it was developed in Japan also. So here test is carried out by placing a cylindrical specimen horizontally. Okay, so आपको horizontally रखना है. So whatever is your cylinder, that is here it is 15 centimeter diameter and 30 centimeter height. So here you have to keep it horizontally and you have to apply load. Okay, that is the thing. So the same compression testing machine that is generally utilized, and that will give the failure along this particular cylinder. ये जो आपका diameter होगा, vertical diameter, उसमें कहीं पे आपका failure आएगा and it will split. So when the load is applied along the generatrix, means जहाँ से आपका fail होगा, then the different types of stresses are developed. So first is vertical compressive stress. One would be vertical compressive stress. I have told you that this portion, it would be under compression. So almost 1/6 portion that would be under compression. Rest of the portion 5/6 it would be under tension. So ये सब tension में आएगा. ठीक है? So here this vertical compressive stress is given by 2p upon pi LD, d square upon r upon d minus r minus 1. So where this r, यहाँ पे जो है आपका particular r and d minus r, they are the distance of the elements from the two loads respectively. So here from the top, जहाँ पे failure ज़्यादा आपका plane आता है, this distance is r and this is d minus r. So we are not interested in this vertical compressive stress. Our main aim is to find out the horizontal stress, tension के लिए, okay? Because we are finding the tensile strength. So this horizontal stress, it is giving your tensile strength, and that will be given by 2 into P, load at failure, divided by pi into L into D, because our load is applied in this direction. So that is 2P into pi into L into D. That P is the compressive load on the cylinder, L is the length of cylinder, that is 30 centimeter, D is diameter, that is 15 centimeter. So easily you can find out this tensile strength of concrete. Okay, so this is the formula that you have to use for finding out tensile strength of concrete using split cylinder test. Okay, so as I told you, that loading condition produces a high compressive stress immediately below two generators to which the load is applied. So this will be under compression, and rest of the portion it would be under tension. Okay, but the large portion corresponding to the depth is subjected to uniform tensile stress acting horizontally, and that is what we are interested. So it is estimated that compressive stress is acting about 1/6 depth, and the remaining 5/6 depth is subjected to tension. तो दोनों मिला के आपका 1/6 of the portion in the top and bottom that would be under compression. Rest of 5/6 depth it is generally subjected to tension. Now we want that हमारा तो टेंसाइल स्ट्रेंथ फाइंड आउट करना है, तो we want कि compression जितना कम हो उतना अच्छा. So in order to reduce the magnitude of high compression stresses near the point, ये जो ऊपर और नीचे वही तो ज्यादा compression ना रहे, तो हमको क्या करना है कि compression को कम करना है. So for that what we can do, near the point of application of load, narrow packing of the strip of the plywood. तो यहाँ पे जहाँ पे लोड आता है तो what we can do कि जहाँ पे लोड अप्लाई करें यहाँ पे प्लाईवुड की शीट रख देंगे, ठीक है, at the top and bottom. So this plywood sheet that we have to keep where we are applying the load. That strip may be 25 mm wide, 3 mm thick, and 30 centimeter long. So as per the length of your cylinder, the size can be decided, and it should be placed between the specimen and loading platens of the testing machine. So by doing such thing, we just try to reduce the compression. So we want that most of the tensile stresses would be developed and least of the compressive stress compression would be there in the specimen. So you can get a more reliable result of tensile strength of concrete. Okay. So there are certain advantage of this split cylinder test. What is the first basic advantage? Same specimen, that cylindrical specimen, that whatever we are using for the compressive strength, the same will be utilized. Also the same testing machine के लिए कोई सेपरेट मशीन की जरूरत नहीं है, कंप्रेशन टेस्टिंग मशीन से ही हम कर सकते हैं. फॉर द फ्लेक्सुरल स्ट्रेंथ यू नीड अ सेपरेट मशीन, बट हियर सेम स्पेसिमेन एंड सेम टेस्टिंग मशीन that we are using for the compressive strength that can be applied. So that is why it is now getting popularity, right? Same specimen use कर रहे हैं, same testing machine use कर रहे हैं. It is also simple to perform. What you have to do, just you have to pass the cylinder and you have to keep it horizontally under compression testing machine by keeping the two plywood sheet at top and bottom, and you have to just apply it proper load. Okay, it also gives more uniform results than other tension test. दूसरे भी tension test है, लेकिन इसकी जो results है that are more uniform as compared to other tension test. And strength determined in the splitting test is believed to be closer to the true tensile strength of concrete than the modulus of rupture, because I have told you that modulus of rupture that is also giving you indirect tension test, but its value, this tensile strength finding out with the help of this split cylinder test, it is more closer to the true tensile strength of the concrete. And this split cylinder strength it gives about 5 to 12% higher value than the direct tensile strength. अगर आप उसको directly tensile tension देके if you are finding the strength, then it is generally observed that a splitting strength, जो भी whatever we are getting using this split cylinder test, it gives about 5 to 12% higher values than the direct tensile strength that we are getting. Now we know now how to find out compressive strength, how to find out tensile strength. Okay, but generally it is observed on field that generally compressive strength we are doing invariably. हम बहुत सारा compressive strength ही करते हैं, and less stress is given upon to find out the tensile strength. Okay, so there are certain studies that are done, and certain types of that relationships that are developed between tensile strength and compressive strength of concrete. So in case if you want to find out tensile strength based on our compressive strength of the concrete, then that can also be done. So just to have that idea कि क्या relation है tensile strength और compressive strength में, so there are number of empirical relationships that are connecting the tensile strength and compressive strength of concrete. And one of the common such kind of relationship, that is this following relationship. Okay, so here as per this relationship, tensile strength is equal to K into compressive strength into N. Okay, where this K, it varies, it depends upon which kind of aggregates that you have used. 6.2 for gravel and 10.4 for the crust rock, and the average value may be taken as 8.0, and this n, it may vary from half to 3/4. So this is a generalized relationship. So our Indian standard, as per our IS 456 of 2000, it gives the following relationship between compressive strength and flexural strength. So you should remember this relationship. If flexural strength is equal to 0.7 into square root of FCK, and what is this FCK? It is the characteristic compressive strength of concrete in Newton per mm square. So in laboratory when we are finding this compressive strength, जब हम compressive strength find out करते हैं, so because normally we have to find out this compressive strength, this is the essential parameter. So you can find out this flexural strength approximately by using this particular relationship. Okay, and when you are actually finding out this flexural strength by casting the particular beam, etc., so you can compare the flexural strength that you have obtained using this formula as well as the actual strength that you have found out using that particular casting of beam. Okay, so this relationship is very important, and this is our IS standard. So you have to remember this. This is the relation between flexural strength and compressive strength. Flexural strength is 0.7 square root of FCK. And normally we are checking in laboratory, जब हम लैब में करते हैं टेस्ट, तो हम compressive strength से भी find out करते हैं flexural strength, and actually whatever by casting the beam also we are finding, and we try to just check the relationship between the both the flexural strength obtained by this particular casting as well as by using this particular formula. Okay, so this is also very important relationship that you should know. Now when we are doing this strength test, compressive, tensile and flexural strength in particular laboratory, there are certain factors that will affect this strength result. So आप अगर वो प्रॉपर कंडीशन फॉलो नहीं करते हैं तो आपका स्ट्रेंथ रिजल्ट डिफरेंट आ सकता है. ठीक है, सो इट मे नॉट बी अ रिलायबल रिजल्ट, यू कैन से. ओके, सो दीज आर द फैक्टर्स दैट यू शुड नो दैट विल अफेक्ट द स्ट्रेंथ रिजल्ट. मैं स्ट्रेंथ की बात नहीं कर रही हूँ, इट्स नॉट द स्ट्रेंथ ऑफ कॉन्क्रीट, इट इज द स्ट्रेंथ रिजल्ट. जो हम रिजल्ट ऑब्टेन कर रहे हैं उसको अफेक्ट करता है. तो व्हेनेवर इन एग्जाम इफ सर्टेन थिंग्स आर आस्क्ड कि फैक्टर्स अफेक्टिंग स्ट्रेंथ ऑफ कॉन्क्रीट और फैक्टर्स अफेक्टिंग strength result of concrete, so accordingly you have to reply, because strength of concrete, that strength of concrete तो जो है वही रहने वाला है, but it is giving the result. So these are the factors that will influence the strength result. So first important thing is shape and size of specimen. अभी हमने इतनी सारी बात की कि specimen सब में different होते हैं. So generally if the strength of 15 centimeter size cube, जो हम लेते हैं 15 by 15 by 15, if it is taken as standard, कि हमने standard ले लिया कि this is standard, the strength of the 10 centimeter cube should be reduced by 10%. That is the thing. So here there is the effect of height to diameter ratio. Okay. So and also this cube specimen जो आपका बहुत ही छोटा है, so more and more restraining effect of the steel patterns will be observed. Okay, though its H/D ratio is 1 in 10 by 10 by 10 10 by 10 by 10 by भी वही रहेगा, लेकिन it's a very small size. So 15 centimeter cube whatever result, this 10 centimeter cube result should be reduced by 10%. Strength of the cylinder of 15 centimeter diameter and 30 centimeter long is generally taken as 0.8 of the strength of the 15 centimeter cube. So this is the variation, large variation. It also depends upon the particular strength of concrete. के high strength concrete होगा effect कम होगा, low strength concrete होगा ज़्यादा होगा. But in general you can say it is 0.8 times the strength of 15 centimeter cube. So cylinder strength is 0.8 times of the cube strength. Where large cubes, 15 centimeters से भी ज़्यादा large cubes when you are adopting, generally no modification of the strength is generally applied. Okay, unless and until it is specified, you should not apply such modification. And there is a height to diameter ratio that we have already discussed how it is affecting the strength result. Okay, that is due to the restraining effect of the steel platings. The plainness of the end condition of specimen and capping material used for cylinder. So this is very important. As you know that in cylindrical specimen we have to apply the capping. So whenever such cappings are applied, that will also affecting the strength result. Also, if you are certain time employing some lubricating material at the bearing surface of the sample, then it will also affect the strength of concrete. So this plainness condition and the condition of the specimen and condition of the specimen, that are very important thing, and that is should be properly checked before loading your specimen. Rate of application of load. So this is the most important part. In each particular strength test, we are having particular specific loading conditions and rate at which you have to apply load. Okay, because it has the considerable effect on the apparent strength of the concrete. Lower the rate of application of load, अगर आप बहुत धीरे धीरे अप्लाई कर रहे हो, the lower will be the recorded strength. Recorded strength भी lower आएगा. The reason behind this is the probable effect of the creep. Basically we are going to learn this what is creep. So that is basically the deformation of structure under sustained load. एक ही लोड के अंदर भी अगर डिफॉर्मेशन कंटिन्यू होता है, that is generally called as the creep. So if at a very slow rate if you are applying the load, then more creep will be observed, and that will give you lower result as compared to faster rate. So this rate of application is also very important. Then state of moisture content of specimen. This is the most important thing. Okay, why we are just taking specimen and just we are keeping it under the testing machine. जैसे हम क्योरिंग टैंक में लाके तुरंत उसको अंदर रखना है, तो ड्राई नहीं करना है. Okay, it influences the observed strength to a great extent. Okay, and if two cubes are made from identical concrete, one is wet, एक है गीला, and second is dry, and if it is tested at same age, the dry cube will give higher strength than the wet cube. Okay, that is generally observed. Okay, so different amount of dryness or wetness we should try to avoid. So to have a standard condition for test specimen, it is usual to test a specimen immediately on removal from curing water tank. So as I told you, कि तुरंत आपको क्योरिंग टैंक में से आपके स्पेसिमेन बाहर निकालने हैं एंड आपको टेस्ट करना है, जस्ट टू अवॉइड द डिफरेंट डिग्री ऑफ ड्राइनेस. ओके, सो दिस कंडीशन हैज द एडवांटेज ऑफ बीइंग बेटर रिप्रोड्यूसिबल देन अ ड्राई कंडीशन एंड विच इंक्लूड्स द ग्रेटली वेरिंग डिग्री ऑफ ड्राइनेस. आपको अगर 1 घंटे बाद किया, 2 घंटे बाद किया, सो दैट वुड बी डिफरेंट ड्राइंग कंडीशन. सो जस्ट टू अवॉइड दिस डिफरेंट ड्राइंग कंडीशन, we should test it immediately. Okay, then largest size of aggregate. This is also very important, and as you know, in each case when we were discussing about specimen size, it was all dependent upon the 20 mm से ज़्यादा aggregate का size है तो आप ये specimen use करो, 20 mm से कम का diameter size aggregate size है, you can utilize this 10 by 10 by 10 cube. And बीम में भी आपने देखा कि 10 by 10 by 50 mm the centimeter cube that beam specimen. So these are all affecting the size of aggregate. So basically this ratio of size of specimen to maximum size of the aggregate should not be less than 4. Okay, for the general specimen. And in case of the cylinder, ratio of the diameter of the cylinder to the maximum size of the aggregate, it may be around 3 to 4. What is the importance of this? Because of this wall effect. What is wall effect? Basically जो mold की जो wall होती है ना, so that will also influence the packing of your concrete, and that is why the largest size of the aggregate, that is very important parameter in determining your particular mold size, and accordingly your strength result will be varied. Also this temperature of the specimen is affecting the strength result, and it is observed that high temperature gives lower result. Okay, so with this I would like to end this, and today we have discussed about how to find out the strength of concrete. That is already we have learned all this compressive strength, tensile strength and flexural strength, as well as all the factors that are affecting your particular strength of concrete. So thank you very much.